Given the formula, what's it? V equals u plus at, and s equals a half u plus v over t. Derive the formula. What we're deriving? We're trying to derive v squared equals u squared plus 2as. Okay, so that's no big deal. So what I'm going to do here is just going to make myself a bit of room. Okay, and we're good. Here we go. Now, so what letters are clearly missing from this formula? What's the letter that's missing? T. To me, I should isolate T. T would be a good thing to isolate. So I'm going to multiply out the S equation first. I'm going to get S equals U plus V all over 2 times T. Would that be all right? And then T, therefore, 2S equals over U plus V equals T. Would that be okay with you guys? Just rearranging the formula. Now, I'm going to go up to V equals U plus AT. Okay, and what I'm going to do is I'm going to sub out the T. So lads, I'm going to sub out the T. And what happens when I sub out the T? What am I putting in instead? 2S over U plus V. Okay, now what I'm going to do next is I'm going to give everything a common denominator in a second, okay? So I'm pretty happy about this because what I'm happy about is I'm about to get the 2as, haven't I? What happens when you multiply out? 2as, yeah? Now, what I'm going to do next is I'm going to give them a common denominator. So what I'm going to do is I'm going to stretch the V over here. Okay. And I'm going to give the V, I'm going to put that over U plus V, which means on top I'm going to need a U plus V as well. This U, I'm going to give a U plus V underneath, which needs a U plus V on top. Excuse the bad writing. Okay. So what I'm going to do now is I'm going to multiply this out and get rid of the common denominator. So it's going to be VU plus V squared equals U squared plus VU. The two VU's cancel. Then I'm going to move the U squared to the left and I'm going to get V squared minus, oh sorry, leave it where it is. V squared equals U squared plus 2AS. Go with that? Okay. Next thing I'm going to do is what's called a dimensional analysis, okay? And a dimensional analysis is basically ensuring that your units add up. You can see it in the corner here, but there's no need for me to worry about that. I'll show you what I mean now. What's velocity measured in? Meters per second, or meters divided by seconds. Velocity here is also measured by meters divided by seconds. What's acceleration measured in? ms minus 2, which is meters over seconds squared. See, you're enjoying yourself. Now, all right, so that's 2 over what? So that's, the 2 is there. But what's the A, guys? The A is m over s squared, and the s, what's distance measured in? Meters. Oof. Okay. Now, does it work? Well, I have to square this, don't I? I have to square the other side as well, don't I? You're checking that the units match up on both sides. That you're not comparing apples to oranges. That you're comparing meters squared seconds squareds to other meters squared seconds squareds. And what's the other side? Meters squareds seconds squared. So they're the same units as each other. Now, so guys, what we're basically saying is that the units on both sides are the same. So when you multiply one side out, it's the same as the units on the other side. Is that okay? That's all we're saying. That's a dimensional analysis.